Good evening, one and all. I welcome you all to Ganesh IAS Academy. In today's session, we'll be seeing science and technology based current affairs from the date January 10th to January 20th, 2024. Let us get into the news articles one by one. The first news that we are going to see for today is Amithe Rasu or Amithu Rasu. So, what is this Amithu Rasu? Why is it in the news? Let us get into the details. Japanese scientists recently detected most powerful cosmic rays seen in more than 3 decades, which has been named Amathu Rasu. Okay, so these are most powerful cosmic rays which were seen in more than 3 decades. So before 3 decades, they have seen a powerful cosmic rays, and then after 3 decades, such an intense, which is most powerful, has been seen again now. Okay, so that is why it is in news, and it has been named after the Japanese sun goddess, that is Amaterasu. Okay, so it is one of the highest energy cosmic rays ever detected in Earth. Okay, what else do we have to understand from this topic? That it has an energy exceeding 240 exa electron volts. So exa electron volts or electron volt is an unit of energy. Okay, measuring energy. So the energy is exceeding 240 exa electron volts. So what is exa here? Exa is 10 power 18 is exa. Okay, we say, right, kilo is 10 power 3, mega is 10 power 6, giga is 10 power 9, tera is 10 power 12, peta is 10 power 15, and exa is 10 power 18. So it is 10 power 18 electron volts. Okay, so this is millions of times more powerful than the particles which are being produced in the Large Hadron Collider, which is the most powerful accelerator ever built on Earth. Okay, so it produces millions of times. I mean, the energy of these particles, these cosmic rays, are millions of times more than the particles which is produced in the Large Hadron Collider in Earth. Okay, so it comes only second to the oh my god particle, another ultra high energy cosmic ray that came in at 320 exa electron volt, which was detected in the year 1991. That is why they are saying that it has been detected after 3 decades. Okay, so in the year 1991 they have detected oh my god particle. Okay, and its energy was 320 exa electron volts, but the Amithu Rasu's energy is 240 exa electron volt. Okay, so Amithu Rasu appears to have emerged from the local void, from where it has originated. It has originated from the local void. So what is the local void here? It is an empty area of space bordering the Milky Way galaxy. So the empty area of space bordering the Milky Way galaxy is called as the local void, and from there only this Amithu Rasu cosmic ray is being emitted. Okay, so here we need to understand what cosmic ray is. Okay, so cosmic rays are high energy particles moving at nearly the speed of light. Okay, 3 into 10 power 8 meter per second, this is the speed of light. Okay, so it is moving at nearly the speed of light, originating from sun, our galaxy, that is Milky Way galaxy, and other distant galaxy. So these are all the sources from where cosmic rays are emerging. Okay, so essentially cosmic rays are charged particles with wide range of energies, and it consists of positive protons, negative electrons, or even entire atomic nuclei which travel through the space and rain down on the earth nearly constantly. Okay, so it is happening continuously, but then its energy varies. And now what we have experienced now, this Amaterasu is the highest energy cosmic ray. That is why we are studying it separately. So they hit Earth's upper atmosphere and then blast apart the nucleus of the oxygen and nitrogen gas, thus generating many secondary particles. Okay, so upon entering the Earth's upper atmosphere, they blast apart the nucleus of the atoms of oxygen and nitrogen gas, thus generating secondary particles. So secondary particles are generated within the Earth's atmosphere. And what happens next? These travel a short distance. I mean, the secondary particles travel a short distance in the atmosphere, and then the same process is repeated, thus creating millions and billions of secondary particles. Okay, so building a shower of billions of secondary particles that scatter to the surface. So these secondary particles are hitting the surface. Okay, so that is how we are measuring it. So this is what happens when cosmic rays are entering the Earth's atmosphere. Now, what is the significance of this cosmic rays? Okay, what can we do by understanding or studying these cosmic rays? So they are crucial for studying astrophysical phenomena and understanding the properties of the particles at very high energy. So for understanding the astrophysical phenomena, we have to study cosmic rays. Okay, so in one of the points we discussed that the cosmic rays travel at the speed of light, and I said the speed of light is 3 into 10 power 8 meter per second. So what is speed of light? What are all the different aspects to it? Let us understand here. So light moves at an incredible speed of 186,000, okay, or 1,86,000 miles per second, which is 3 lakh kilometers per second. Okay, it is 3 into 10 power 5 kilometer per second and 3 into 10 power 8 meter per second. Okay, this is what I mentioned in the previous slide. And then it is equivalent to almost 700 million miles per hour, or more than 1 billion kilometers per hour. Okay, all the units are one and the same. Okay, I mean all the numbers are one and the same with different units here. So that's fast enough. I mean, this speed of light is fast enough to circumnavigate the globe 7.5 times in just 1 second. In just 1 second, the speed, with the speed of the light, we can circumnavigate Earth 7.5 times. Okay, so these are all the facts which we need to know here. This is it with Amaterasu cosmic rays. The topic that we are going to discuss now is Proba 3 mission to be launched by India. So what is this Proba 3 mission? And it is the mission of which space agency, and why is India launching this mission? All these details we must have to understand. Let us get into the details. India will launch the European Space Agency's pioneering Proba 3 mission in September 2024. Okay, so it belongs to European Space Agency, ESA. Okay, and this ambitious project marks the world's first precision formation flying. Okay, so this is the first time precision formation flying is done. Okay, this is the first precision formation flying mission with a pair of satellites. So what is precision formation here? They will be having two satellites, and then they will be placed at a precise location, and then its position will be fixed there. That is precision formation. There won't be even slightest of variation in their position. Okay, it will revolve around the Earth in this position. Okay, so with a pair of satellites designed to operate in unison as a large rigid structure in the vastness of the space. Okay, so the duo of satellites, the two satellites, will align to create a 144-meter long solar coronagraph. So here there will be one satellite, another satellite will be placed here, and this satellite will be shedding its shadow. Okay, it will hinder the light from the sun. Okay, so it will create a shadow on this, that thus a coronagraph is created, and this distance between this satellite and this satellite, satellite 1 and satellite 2, is 144 meter. Okay, they will be placed in such precise locations or positions. So what is coronagraph here? Coronagraph is an instrument that will allow the scientists to study the sun's corona with the unprecedented proximity and detail. So sun's corona, we'll understand what sun's corona is and why is it difficult to study it now, and with what ease can we study the sun's corona with the help of proba 3. All these details we must have to understand. So if you look at this, sun's atmosphere has different layers like photosphere, chromosphere and corona. Okay, here this corona is the outermost layer, and here the temperature at that layer can be 10 lakh degrees Celsius. Okay, it can be 10 lakh degrees Celsius, and then it is visible only during the eclipse. Okay, with bare eyes we can view corona only during eclipse. At other times we cannot see it. Okay, and there are other layers like chromosphere and photosphere also of the sun, but with this experiment, with proba 3, we are going to study the corona only. And this photosphere is the innermost layer, and then the middle layer is called the chromosphere, which is also called the color sphere. See here, if you notice that the photosphere's temperature is 6000 degrees Celsius, that is the average surface temperature of the sun, we say. Okay, and then the chromosphere's temperature is 4000 to 50,000 degrees Celsius. It will range from one location to another. Okay, it will vary. And then the corona's temperature is 10 lakh degrees Celsius. Why is such high temperature there in sun's corona? All these details can be understood only if we understand what corona is, what are all the constituents of corona, why is such high temperature happening there. So we need to study corona with the help of proba 3. Okay, so this region, that is the corona, sun's corona region, known for its ghostly glow, has been challenging to observe due to the blinding brightness of the solar disk. Okay, the solar disk blinding brightness is making this corona dull. Okay, so we cannot view it properly. So with the help of proba 3, we can view it. So proba 3 aims to change that by mimicking an artificial eclipse in the space, providing a continuous view of corona close to the solar rim than ever before. Okay, so we cannot be waiting for eclipse to study the sun's corona. Okay, so here they are going to mimic it artificially. So they are mimicking artificial eclipse with the help of 2 satellites. Okay, so the mission's success hinges on the precise positioning and the coordination of the 2 spacecraft. So only when they are in precise position and coordination, that solar eclipse kind of or eclipse kind of mimicking can take place. Artificial mimicking can take place. So the satellites will maintain their relative positions with millimeter scale accuracy. So only if they are with that accurate positions, this is possible. So it is millimeter scale accuracy, which is a feat akin to a carefully choreographed cosmic dance. So here cosmic dance, by cosmic dance they are mentioning the eclipse here. Okay, cosmic dance. Okay, it is like a term here. Next, what are all the components of this proba 3? Proba 3 consists of 2 small satellites. What are they? One is a coronagraph spacecraft, and then the other is the solar disk shaped occulter spacecraft. Okay, so by flying in a tight formation about 150 meters apart, the occulter will precisely cast its shadow on the coronagraph's telescope, blocking the sun's direct light. Okay, we'll see the picture, and this will allow the coronagraph to image the faint solar corona in visible ultraviolet and polarized light for many hours at a time. Okay, so this is what we need to know here, and this is how it will be looking. Okay, so this is that coronagraph and this is that occulter. Okay, this occulter will create shadow on the coronagraph, okay, and that shadow will be acting as a solar eclipse. Thus, the corona of the sun can be viewed continuously for many hours and it can be studied. This is what is the aim of this particular mission, that is Proba 3 mission of European Space Agency. So this formation flying opens up possibility for more complex and versatile space systems in future and potentially revolutionizing how we approach tasks like Earth observation, telecommunication and deep space operation. Okay, so since this formation flying is happening for the first time, we can apply such formation flying for many other applications, okay, like Earth observation, telecommunication or deep space exploration. So this is a great thing that is being done by European Space Agency. And how is India or how is Indian Space Agency going to collaborate with this? That is also important. Okay, so the launch vehicle of the choice for this mission, Proba 3 mission, is India's reliable PSLV. Okay, PSLV XL variant. Okay, which is operated by Indian Space Research Organization. So there is a collaboration between ESA and ISRO, European Space Agency and ISRO, and this exemplifies the growing trend of international partnership in space endeavors, pooling sources and expertise to push the boundaries of what's possible. Okay, so they are pooling sources and they are creating partnerships here. Okay, PSLV is going to be used, PSLV XL variant. And what is the significance of this mission? This Proba 3's unique positioning will provide new insights into the origins of coronal mass ejection eruptions of the solar material that can disrupt the satellite and power grids on Earth. Okay, so we have something called as coronal mass ejection eruptions which is happening from the solar surface. Okay, so this is actually disrupting satellites functioning and also disrupting many power grids in the Earth, on the Earth. Okay, so we can better study these coronal mass ejection and we can avoid its effect on the satellites and power grids if we understood the coronal mass ejection and the corona. Okay, next is this mission will also measure the total solar irradiance, tracking changes in the sun's energy output that may influence Earth's climate. Okay, so Earth's climate is influenced heavily by the sun's irradiance or the incoming solar radiance. Okay, radiation. So this can be better understood with understanding corona. Next is the Proba 3's formation flying also serves as a test bed for future multi-satellite missions. Okay, so it serves as a test bed for multi-satellite missions in the future. Okay, because this itself is a multi-satellite mission, right? More than one, and it is going to do this formation flying for the first time. This is what we need to know about the Proba 3 mission of European Space Agency. The topic that we are going to discuss now is thylakoid membranes. What are thylakoid membranes? Let us understand that and why is it in the news. Researchers at the University of Liege, Belgium, have identified thylakoid microstructures in fossil cells that are 1.75 billion years old. Okay, so they have found thylakoid microstructures in the fossil cells which are 1.75 billion years old. So what are thylakoid membranes here? They are little pouches which are located in the chloroplasts of the plant. Okay, all the plants that are involving in photosynthesis will be having chloroplast. Okay, so these chloroplasts, inside these chloroplasts there is a particular pouch called as thylakoids. Okay, so they store chlorophyll. They are the ones, the thylakoid is the structure which stores chlorophyll here. Okay, and what chlorophyll is? It is the substance in plant that reacts to the sun and triggers photosynthesis. We all know this from school level science. Okay, so these membranes are dense and they are mostly galactolipid protein containing bilayers. Okay, so they are galactolipid protein containing bilayers in which photosynthesis occurs in photosynthetic organisms, the plants here. Okay, Are plants the only photosynthetic organisms? No, there are also certain bacteria which are photosynthetic. We'll be understanding that here. Okay, so this is how the thylakoid looks, and this is a chloroplast. Okay, a leaf is there and a tiny part of leaf is zoomed here. Okay, this is chloroplast, and inside chloroplast you have this thylakoid. Okay, and inside thylakoid you will be having chlorophyll, which is responsible for photosynthesis to happen. Okay, the light energy is getting converted into food energy here. Okay, so what are all the recent findings which is related to thylakoid? What have the researchers found here? So the oldest known fossil thylakoid date back approximately 550 million years, but the researchers now have identified thylakoid membrane in a fossil cell that are 1.75 billion years old, that we already know. So these findings suggest a minimum age of divergence between cyanobacteria with and without thylakoid. Okay, so initially cyanobacteria was there in waters, okay, billions of years ago. Cyanobacteria was there, but over a period of time, these cyanobacteria had thylakoid. Initially, they were not having thylakoid, but after some time, they acquired this thylakoid structures in them, and thus they become photosynthetic. Okay, so these findings suggest a minimum age for divergence between between cyanobacteria with and without thylakoids. Okay, so it presents a possibility that the development of thylakoids might have significantly contributed to the phenomena known as great oxygenation. So what is this great oxygenation? That we have to understand. Before that, we need to know what cyanobacteria is and how is it going to help in great oxygenation. Okay, so what are cyanobacteria? These are also called as blue-green algae, and they are microscopic organisms found naturally in all types of water. So these single-celled organisms live in freshwater, brackish water, or even marine water, and these organisms use sunlight to make their own food. Okay, so they are single-celled organisms and they live in different conditions of water, freshwater, brackish water, and even salt water or marine water, and they use sunlight to make their own food because it is photosynthetic. So in warm, nutrient-rich water, these cyanobacteria multiply quickly, creating blooms, and that spread across the water surface. This is what is happening, and it needs nutrients to survive. Okay, so only with the help of nutrients they thrive. So the blooms can form at any time, but most often they form in late summer or early fall. So this is it with the cyanobacteria at present. But now we have to understand that oxygenation, great oxygenation event, and how is it related to thylakoid and the cyanobacteria. Let us understand that. So around 2.4 billion years ago on Earth, the oxygen released by the cyanobacteria filled in the ocean and made its waters rich in oxygen. Okay, so before 2.4 billion years, these cyanobacteria filled the oceans with oxygen. How did they do it? Because they were photosynthetic, and that photosynthetic material that these bacteria needed was thylakoid. Okay, so that is how we are linking thylakoid here. So over time, this oxygen started escaping into atmosphere. Initially it was in water, and over a period of time it started escaping into atmosphere where it reacted with methane. Okay, so this oxygen reacted with methane. So methane is there, CH4 plus oxygen will give carbon dioxide and water. Okay, so if we have to balance it, it has to be like this. So methane reacting with water, forming carbon dioxide and water. Okay, so initially methane was present in Earth's atmosphere. Only after the release of oxygen from the waters, which is created due to cyanobacteria, into atmosphere, this methane got depleted little by little. Okay, so as more oxygen escaped, methane was eventually displaced and oxygen became a major component of the atmosphere. This is how oxygen became a major component of atmosphere, and this event is known as great oxidation event or great oxygenation event. Okay, so cyanobacteria is the one which has helped this great oxygenation event. And what material inside cyanobacteria has helped? It is the thylakoid, because it is the one which contains chlorophyll. So that is how we are linking here. So thylakoid membrane and thylakoid. The topic that we are going to discuss now is Einstein probe. What is this Einstein probe? Let us get into the details. Recently, China has launched a novel astronomical satellite named Einstein probe into space. And the objective of this mission is to investigate mysterious transient phenomena in the universe that resemble flickering fireworks. So they are going to understand these mysterious transient phenomena in the universe. So this Einstein probe represents a mission which is led by Chinese Academy of Sciences, which is focused on time domain high energy astrophysics. What is the academy here? Chinese Academy of Sciences. So who are all the mission partners of this Einstein probe? There are two mission partners. One is the European Space Agency and the other is the Max Planck Institute of Extraterrestrial Physics, which is located in Germany. Okay, so these are all, these two agencies or organizations are mission partners of Einstein probe. Einstein probe of China. And what is the objective here? To monitor the sky in the soft X-ray band. So they are going to monitor sky in the soft X-ray band, and also to detect intense bursts of high energy light originating from celestial objects like merging neutron star and black hole. So merging neutron star and black holes create intense high energy light. So that is going to be studied with the help of soft X-ray band. That is what is the aim or the objective of Einstein probe. What else do we have to know? What is the significance of this mission? One is, unlike traditional X-ray telescopes, this distinctive design of Einstein probe enables it to simultaneously observe nearly 1/12 of the sky. So it will be observing 1/12 of the sky, and then this capability allows the identification of new sources as they emit X-rays, thus facilitating in-depth study of known as well as new celestial phenomena over extended time frames. Okay, so they are going to study this with the help of X-ray telescopes. So it will identify light emissions from gamma ray burst, supernovae, flares from distant stars, and events within the solar systems, including emission from comets. All these are going to be studied with the help of Einstein probe. Okay, so this is what we need to know about Einstein probe of China. The topic that we are going to discuss now is ISRO's second generation distress alert transmitter. So what is this distress alert transmitter, and what are the unique features of the second generation of these transmitters? Let us understand one by one. Recently, the Indian Space Research Organization ISRO has developed an improvised distress alert transmitter with an advanced capability for fishermen at sea to send emergency messages from the boats. Okay, so the fishermen can send emergency messages from the boat with the help of this device, and then the people who are at the shore will go help them at the time of emergencies. Okay, so it is a device used for sending emergency messages from the fishing boat. Basically, these are DATs or distress alert transmitters. So what is the evolution of distress alert transmitter, and what are all the new features of the second generation transmitters? Let us understand. Talking about the evolution, the first version of this DAT has been operational since 2010, and using this information, the Maritime Rescue Coordination Center coordinates to undertake search and rescue operation to save fishermen in distress. Until now, more than 20,000 DATs are being used. So how does this work, this DAT work or distress alert transmitter work? The messages are actually sent through a communication satellite and they are received at the central control station, that is Indian Mission Control Center, where the alert signals got from the boats. Alert signals are decoded for the identity and location of the fishing boat. Okay, say for example, here is where the boat is. From here, signal is sent because they are facing some distress situation. The signal will go to communication satellite and then it will, this is the communication satellite, and then it will reach the central control center or station, that is Indian Mission Control Center. From there they will identify and then locate the fishing boat. So this is how it is being done. The extracted information is forwarded to Maritime Rescue Coordination Center, okay, under Indian Coast Guard. Okay, this itself can be asked as a question, that Maritime Rescue Coordination Center is a part of, or it is an arm of which of the following bodies? That is Indian Coast Guard. Okay, what else do we have to understand? The additional features of the second generation of DAT. What are they? One is real-time acknowledgement. Earlier, the signals will be sent, the signals will be received, and then they will come for rescue. But then, in this meantime, no communication will be made between the two. Signals are sent and they are going for rescue operation, but then no communication is made. Real-time communications or acknowledgement is not being done. But in the new second generation DAT, this feature is possible. So besides sending distress signal, the DAT second generation has the facility to send back acknowledgement to the fishermen who activate the distress alert from the sea, and this will provide them with assurance that the help is on the way. This is very important, right? They must be assured that the help is on the way so that they can stay confident even at distress situations. So there is two-way communication also. So in addition to sending distress signal, it can also receive messages from the control centers like we discussed, and then it will help in providing advance warnings about the adverse weather, cyclone, tsunami and emergencies. Okay, so earlier the system was the people who are in the boat will be sending signal to the rescue centers, but now if any emergencies are going to happen which the center know, they can send message to the people who are at the fishing boats, in the fishing boats. Okay, next is 24/7 basis, that is the service of this second generation DAT has been declared operational 24/7. Okay, what else? Potential fishing zone updates are also given with the help of the second generation DATs. How? This transmits regular updates on potential fishing zones for fishermen, thus aiding them in maximizing catches and saving time and fuel. Okay, so they will be in search of fishes. Okay, so these centers are actually helping these fishing boats by sending messages that these are the locations where you can find maximum fishes. All these are done with the help of satellite imagings only. Okay, next is Bluetooth connectivity is also there. How? It can connect to mobile phones. I mean, the DATs can connect to mobile phones via Bluetooth, thus allowing messages to be read in native languages through a dedicated app. Okay, so they can select their languages with the app. Okay, so easily the messages can be communicated. Next is Sagar Mitra. There is another web-based network management system called as Sagar Mitra. So the central control center has a web-based network management system called Sagar Mitra, which maintains a database of the registered DAT second generation DATs. Okay, so here this web-based network management system is maintaining a database of all the registered second generation DATs. Okay, so this is what we need to know from this topic. The topic that we are going to discuss now is bamboo composites. Okay, so what is this bamboo composites? Let us understand, and why is it in the news? Recently, on the second day of the India International Science Festival 2023 in Faridabad of Haryana, the focus was on know-how technology of the bamboo composites. So what are bamboo composites? They are materials that blend bamboo fibers with other substances, thus forming a composite material. What is a composite material? Mixture of two or three. Okay. So here the bamboo fibers are going to be blended with other substances, thus forming a bamboo composite material. So these composites utilize bamboo's strength, flexibility, sustainability for versatile applications in construction, furniture, and even various industries. So how bamboo is better than teak, that they are giving here, that in just 3 to 4 years mature bamboo can be used for bamboo composite. In contrast, teak wood takes 30 to 40 years. Here it is just 3 to 4 years, but teak takes 30 to 40 years for it to be used. Okay. So the resulting bamboo composite product shares similarities with the teak. See, bamboo as such is flexible, it has strength and all other things, but these bamboo composites are having superior strength, flexibility and sustainability when compared to teak. Okay. But it boasts improved durability, dimensional stability, high strength and density when compared to teak. What do we have to understand here is about the technology. Who has developed this technology? So it was developed by CSIR Advanced Material and Process Research Institute, Bhopal. Okay, so what is the significance of this technology? The bamboo composite can be used in various sectors, especially in aerospace, and it has the potential to yield future products akin to wood, but with harvest cycle 10 times faster. We already saw. Okay, for bamboo it is just 3 to 4 years, but for other woods, hard woods, it is 30 to 40 years. So it is 10 times faster. The harvest cycle is 10 times faster. Here the technology has the potential to attract micro, small and medium enterprises and contributing to achieving sustainable goals like Atmanirbhar Bharat, Swachh Bharat Abhiyan and then Swachh Bharat Abhiyan. So in all these components, that is self-reliant India, clean India and other things, these bamboo structures can be used. Okay. So there is a national bamboo mission for the development of bamboo sector. Okay. So national bamboo mission, which was launched in the year 2006-7 as a centrally sponsored scheme to promote the growth of bamboo sector. Okay. So there is this Indian International Science Festival in which this bamboo composite was launched. Okay, so we need to know a little detail about this festival also. So it is a science movement which was spearheaded by the scientists of our nation who are with Swadeshi spirit. Swadeshi means self-reliant or Indian. Okay, Swadeshi. It was organized by Ministry of Science and Technology, Ministry of Earth Sciences, Department of Space and Department of Atomic Energy, all of them in partnership or collaboration with Vijnana Bharati. Okay, so this is what we need to know about this topic, that is bamboo composites. Okay, so with this we have come to end of today's session. I hope you found the session to be very useful and informative. Let us see in the next session. Thank you all.